So many thanks for the invitation to come to this workshop, and as you will see, it's very nice to see such a European-wide organization rising. And I would like to introduce you to the RAPAS project, an initiative we created about 5 years ago with William Tullio and Michel Denfeld. And particularly William Tullio, it was maybe yes, 6 years ago during a workshop gathering the Pro-Am project, warned us that Gaia mission was able to provide a lot of alerts, but in fact, most of these alerts were orphan of observer. And he wanted at that time to promote the interest for the amateur community to follow and to monitor such alerts coming from the Gaia mission. And Michel Denfeld joined us also because of his strong interest about supernovae and a galactic event where amateur could provide a lot of data. And so you see this organization, which has been founded 4 years ago, and we have to thank Paris Observatory Scientific Council, who funded us, and particularly to manufacture these filters. I'm just going to present you this initiative. So we were, thanks to this API, Action Pluriannuelle Incitative Pro-Am, funded by the Scientific Council of Paris Observatory, we got finance during the last 4 years to help to manufacture filters, spectrograph, and we organized a first amateur network in France to answer to these events coming from either solar system object or optical alert or multi-messenger alerts. Up to now, we have created a web page in the Gemini portal. The Gemini portal, also hosted by Paris Observatory, is a portal gathering all the Pro-Am collaboration we have in France. And so you have a RAPAS page dedicated to our collaboration. And then we gathered on the IMCC webpage all the tutorials and data we gathered during 3 workshops we organized during the last 3 years. Up to now, we have nearly 80 registered telescopes, and we deliver to 50 observers a set of 3 filters to unify the photometric data we provide in using the Gaia photometric system. And we designed two new high sensitivity, low resolution spectrograph to be able to provide spectral energy distribution attached to some of these alerts. And then the purpose is to assess the photometric accuracy of the network. And we start last year to react to astrocolibri selected alerts. And thanks to a plug, to a filter performed by Fabien Schussler team, we have a device to filter astrocolibri alerts to feed in the RAPAS network. So what we intend to do is today to answer to 3 kinds of alerts. This could be either solar system objects, So it was formerly the Gaia-Fun SSO alert system to follow the asteroid detection performed by Gaia. And now we move to answer to the near-Earth asteroid alerts coming from the MPC. So to keep a track on this new near-Earth objects crossing the Earth orbits. The second family of alerts are optical stellar or extragalactic alerts coming from optical survey like ZTF, CRTS, and we would like to be ready at the end of this year to answer to some of these LSST Vera Rubin alerts. And the third family, the topic of today, is the multi-messenger astronomy alerts, where amateur telescope could be a nice way to answer to these alerts, thanks to the fact that most of these telescopes have provide a wide field of view thanks to the short focal length we are using. Here you see an histogram of all the registered telescope to the RAPAS network. So you see most of these telescopes are around 200 millimeters, 300 millimeter wide diameter, but some of these telescopes go to 80 centimeter diameter. Here you see the field of view covered by this telescope, and the interesting feature comes from some of these telescopes covered more than 1 square degree of field of view. And here you have a mix of these two data we call géométrique étendue with the multiplication of the square meter of the aperture and the square degree of the field of view. And so you see the interesting histogram, and also you have a mix of these two features, which could be interesting. Here you have the clouds of this facility between the focal length, the numerical aperture, and the field of view. So that's you have with such a database, you understand, of course, that we are ready to create some specific filters also to address, according to the alerts, the right telescope, which could be either able to deal with very high magnitude or to deal with a wide field of view to retrieve the optical counterpart of an alert. Here you see the distribution in France of all these registered telescopes. So from Brittany to West Brittany to Alsace, and from the south part of France and up to north part of France. We have a lot of observers, so ready to deal also with the cloud coverage we may have in France. And of course, it is a part of my conclusion, we are ready to move also to an international wide network or European wide network with such a French route. But so this is the position. So the idea, I came to Paris Observatory so 4 years ago after a Gaia workshop to say, hey, you know, the photometric system coming from Gaia is very interesting, because Gaia is using a very wide spectral band filters, which could provide an enhanced sensitivity to amateur telescope. And during several workshops, I was looking for these filters, and at the end, I realized that, in fact, the Gaia mission didn't manufacture such filters, and this spectral band was coming only from the from the connection between the CCD, the sensitive CCD, the spectral band provided by the CCD and prism, which has been fitted just in front of two rows of CCD. And in fact, these filters were not existing, even in the professional community. And so I proposed to the Paris Observatory to develop such filters meeting the Gaia spectral band. And we have done such a thing. And also the interesting thing coming from the Gaia catalog is the fact that you have a very deep catalog going above magnitude 20. So in these three bands, and this magnitude are provided from through a telescope working outside of the Earth's atmosphere, so giving you really the stellar magnitude, which is, as you know, an illumination defined outside of the Earth's atmosphere. And the amateur community developed several software using this Gaia catalog, and particularly Marc Serrault performed an extract of this Gaia catalog. The name is RAPAS, and such a catalog is today used by Prism, MoneyWin, AstroImagy, Cyril, Tycho Tracker, and we have also AstroPy Suite and STDPipe able to deal with the Gaia catalog. Also coming from this Gaia catalog is the nice photometric accuracy provided for all the stellar sources you may have in your field of view. And so 4 years ago, it was in 2022, yes, 3 years ago, we manufactured a first batch of such filters. You have the effective spectral band of these filters, which have been defined with Michel Denfeld, and which was manufactured by a supplier, MCM, who developed multi-coated filters. And so he provides us with these tuned filters tuned to the Gaia spectral band. And so today we manufactured 2 batches of these filters. The first batch was delivered at the end of 2022, and the second batch was delivered during the this first semester of 2025. And we have up to now, you see here, nearly 50 amateur astronomers equipped with this set of filters. They are distributed here, and you see the distribution of the equipped telescope with these filters. We start also to tune the accuracy of each observer and to perform this photometric reduction in using 3 selected area well-known field of view, which was introduced in the 80s by Science Telescope. And you see such task where we perform the acquisition on this field of view. So you see from my telescope, I'm able to cover more than a square degree and be able to go up to more than magnitude 20 in 10 minutes of exposure with these 3 filters. And you see here how we perform a nice photometric reduction when you compare the magnitude we measure versus the Gaia catalog magnitude in these 3 bands. And you may notice here that we detect some sources which are brighter than in the Gaia catalog. And so, of course, we are already detecting source, variable source, or emitting rising source when we compare this source to the Gaia catalog. So we invite all the amateurs to do such a task to tune the accuracy of the magnitude they are providing. And in May 23, we have a very nice supernovae in Messier 101, and we start to follow such supernovae. And you see here the first light curve we provide in using the three Gaia band to provide versus the time the light curve of this supernovae. And here the color index provided by the two-colored filter coming from Gaia, and we were able to track, to monitor, so the change of temperature of or color index of this supernovae. And last year we plugged RAPAS to Astrocolibri, and thanks to the work performed by Fabien teams, we developed a RAPAS filter from the Astrocolibri, and we provide every week a list of maximum of 10 alerts. And Fabien provides us also a poll process to allow RAPAS observer to decide do we go on with such a target on the next week, or do we stop and do we move to new targets coming from this RAPAS filter on the Astrocolibri outputs. So you see here the message we received on Friday, and you are able to answer to this poll and tick the targets you could be ready to follow the coming week. And here are some things. For instance, last summer also we answered to a gamma ray burst, and here are the event we detect. And we created last year also a spreadsheet to allow all of the observers to deliver their data at once during the night or the following day. And thanks to this spreadsheet facility, this allows also then to provide a GCN circular answer to such alert. And here are the very first GCN we provide to NASA facility. And I may share with you this spreadsheet to show you how it's working today. Where it is, I have to, yes, to flow here. No, this is, yes, whatever. I may show you if you have questions just after. So here is another example, a supernova from the beginning of this year we follow during nearly 3 months. And we provide, so you see here the light curve in the GBP, G, and GRP band of Gaia, and how the color index is moving according to the magnitude of the target. So you may guess how the target is going through an Hertzsprung-Russell figure. So the second step of RAPAS is a spectral initiative. So the interest of Michel Denfeld was also to be able to provide a spectral energy distribution to the alerts we could monitor. And thanks to the help of Christian Buil, we developed 2 prototypes of very sensitive spectrograph. We call it LP200 and StarX VLR, very low resolution. In the amateur community, we have the LP600, which is a well-known spectrograph in the amateur community, and we developed a lower resolution using a 200 groove per millimeter grating to enhance the sensitivity of this spectrograph. And similarly, Christian Bull developed the StarX spectrograph, and we developed a version using a 150 groove per millimeter. And to show that the purpose was to show what is the maximum of magnitude we may reach with a class of 400 millimeter telescope. And we performed such trials during last year and this year to show that the LP200 attached to 280 millimeter telescope, we were able to get a spectrum on a supernovae quoting at more than 18 magnitude. And with TGMS, which is a 600 millimeter telescope, which is in the southern suburb of Paris, we show that we were able to provide such a kind of spectrum on star supernovae, and to show that we were able to measure the Z, the spectral shift of the target, thanks to this the achieved resolution we got from this spectrum, and also to detect some emission line, even with a low resolution, but to help the classification of such alert. So to conclude, so we have organized a new community of amateur observers during the last year, and we are now ready to provide the data, and we are also ready to welcome other amateurs. And what we would like also is to enlarge this community at a European scale or even an international scale. What we would like also is to get additional funding to manufacture other set of filters, to equip, to distribute such a set of filters to the amateur community abroad. What we welcome also, we invite all the RAPAS observers to join the BHTOM initiative and Kilonova Catcher initiative to provide data also to this collaboration. And this year, so we will have several rendezvous. What we would like is to improve the pipeline to answer to this three family of alerts: solar system object, optical alerts, and optical counterpart detection coming from multi-messenger astronomy. In April, between April and August, we financed an internship from a Master 1 a student, Martin Grandidier, to improve the design of this set of filters to enhance the sensitivity we provide to amateur astronomers. We will contribute to the Gemini Program workshop during the SF2A Congress this year in Toulouse between the 4th and the 6th of July, and we will have a special session dedicated to photometric reduction for RAPAS. And we are preparing an internship and a mission at Observatoire de Haute-Provence this summer. And we would like very happy to welcome the ACME community to see how we may develop this pipeline to provide data and to archive this FITS file for processing. And to enhance our capability to provide GCN and TNS circulars. And what we would like to prepare is to plug in RAPAS, so this Vivona capability, which will be introduced this afternoon. And what we would like also is to prepare a paper to publish this capability, and particularly this photometric capability we provide to the amateur community. And what we would like to also is to fix the definition of these two spectrograph prototype to equip a small set of maybe 5 or 6 telescopes to be able to provide the spectral energy distribution attached to some of these alerts. So for next year we are looking for fundings, so to manufacture a third filter batch, and maybe to be able to have a mass production of this filter batch to answer to the international amateur community, to equip them with this same set of filter instead of this, you know, the Johnson cousins or trichrome RVB filters usually used by the amateur community. And so what we would like is to enlarge this network, and maybe this could be meaningful thanks to the ACME initiative to start a European amateur network. And what we would like also is to be ready next year to plug to Vera Rubin alerts. We understand from Julien Peloton that Vera Rubin will be able to provide a lot of alerts, but if these alerts are rising under magnitude 17, Vera Rubin will be saturated and not able to provide the monitoring of such alerts. So this is my concern is also to see how we may build this filter on the Vera Rubin alerts. And what we would like also is to get the funding next year to manufacture a small batch of this optimized spectrograph LP200 and StarX, meeting the requirement of few telescopes. What we intend to do is to equip 400 millimeter class diameter telescope or above. And we show that such telescope with less than 1 hour of exposure is able to provide the spectral energy distribution of alerts up to magnitude 20. Also maybe to be connected to the PESTO ISO initiative, and so be able to provide next year with an, I would say, a more robust pipeline, an ability to provide to GCN and to TNS circular, and also to give to the professional community an access to the FITS archive to allow other process. And also what we would like to be ready also is, you know, at the end of next year, we will get the Gaia DR4 catalog, which will be also an enhanced catalog with more than nearly 10 years deep Gaia observation. Here you have the bibliography. Thank you for your attention.